Suppose that a, b, c, and d are positive integers satisfying all of the following relations. We're given that a, b, c, d is equal to 2 to the 6th times 3 to the 9th times 5 to the 7th. And we're also given the LCM of every pair of numbers between a, b, c, and d. What is the GCD, or greatest common divisor, of a, b, c, and d? So for this problem, we're going to want to look at each prime factor separately so that we can figure out how many 2's, 3's, and 5's are in the prime factorization of each variable. So it's clear that a, b, c, and d can only be divisible by 2, 3, or 5 as its prime factors. So we'll let a equal 2 to the something times 3 to the something times 5 to the something. I'm going to intentionally leave the exponents blank and we'll fill them in. Same with b, c, and d. And we know that their product is 2 to the 6th times 3 to the 9th times 5 to the 7th. So let's start with the prime number 2. Now notice that out of the 3 LCM equations that involve a, so these 3. Now look at the exponents on the prime factor of 2. You see that each of these LCMs contains 2 cubed. This suggests that perhaps a should be 2 cubed times something. And moreover, this is in fact true because if a was not divisible by 2 cubed, then each of the numbers b, c, and d would have to be divisible by 2 cubed. Okay, so if 2 cubed does not divide a, then 2 cubed divides b, c, and d. But the problem with this is that BCD is going to equal 2 to the 9th times something. But there are not enough 2's because ABCD is equal to 2 to the 6th times some odd number. So therefore, A must be 2 cubed times some odd number. So next, if we look at the remaining 3 equations, we see that LCM of B and D is 2 squared, LCM of C and D is 2 squared. This suggests that D should be 2 squared. Again, we're ignoring all of the prime factors of 3 and 5. And this has to be true because if D was not 2 squared, then both B and C would have to be divisible by 2 squared, and we again get a contradiction because ABC would be divisible by 2 to the 7th. Okay, so now we know that D contains 2 squared. Lastly, among B and C, it turns out that we cannot actually determine which of B or C is divisible by 2, but we know that one of them has to be. It does not really matter for this problem, as we'll see in a bit. We'll assume that B is divisible by 2, C is not. And we just do the same thing with the factors of 3 and 5. So let's look at the prime factor of 3. Let's see. So in particular, let's look at the 3 equations that contain C, and we'll see why. Each of the 3 LCM equations that have C has to be contains 3 cubed as the exponent. So this suggests that C should be divisible by 3 cubed. And in a similar way, this can be proven because if C was not divisible by 3 cubed, then each of the numbers A, B, and D would be divisible by 3 cubed. And C would not be divisible by 3 at all. And it can be shown that this leads to a contradiction because if A and B were both divisible by 3 cubed, then the LCM of A and B would be 3 cubed times something. So therefore, C has to be divisible by 3 cubed. That takes care of the 3 LCM equations involving C. Now let's look at LCM of A and D. Right? Because the LCM of A and D contains a factor of 3 cubed as well, we know that one of the variables A or D should be divisible by 3 cubed. However, looking at this second equation, or this first LCM equation involving the LCM of A and B, it cannot be A. Therefore, D must be divisible by 3 cubed. So that takes care of all of the equations involving the LCM of C or D. Lastly, the LCM of A and B is divisible by 3 squared. Therefore, we see that one of A and B must be divisible by 3 squared. And in order for the product to be divisible by 3 to the 9th, the other variable must be divisible by 3 only. So this takes care of the prime factor of 3. Lastly, we're going to look at the prime factor of 5. Similarly, we notice that the first 3 LCM equations each contain a factor of 5 cubed. By the same reasoning with the prime factor of 2, we conclude that A has to be divisible by 5 cubed. Okay, so now let's look at the remaining 3 equations involving B, C, and D. So we see that the LCM of any pair of B, C, and D is divisible by 5 squared. Now, in order for the product of A, B, C, D to be divisible by 5 to the 7th, it turns out that we need 2 of the variables B and C to be divisible by 5 squared, and the other to be divisible by, not divisible by 5. So having B and C be divisible by 5 squared and D not divisible by 5 is one way of doing this. Now again, it doesn't really matter which variable is divisible by 5 or not, because we're going to be looking for the GCD. And by definition, the GCD is by taking the minimum exponent for each prime factor. So now we can simply compute the GCD of A, B, C, and D by looking at the minimum exponent for each prime factor. So 2 to the 0 times 3 to the first times 5 to the 0 equals 3. The answer is C.